Hello everybody. So guys, is there any doubt? Any questions you have? Okay. So you have a quiz tomorrow as announced earlier, starting 4 o'clock. Okay. So is there any question? Any doubt? Okay. If not, we will start the tutorial problems. Just hold on. Yeah. So last week we looked at some problem from chapter number 4, and one of the problem we solved was 413. Okay, and today actually I posted on Google Classroom the solution of 413. Okay, full solution. So I realized that while explaining last week, so I was not sure whether you got it fully or not. So I thought about solving it basically by two methods. So the problem was, if you remember, so there is a inclined plane like this one. There is a mass m here. There is a spring goes like this one, and distance between the end of the spring and the wall is s. Okay, let's say d. Okay, and this is 60 degree. I think 30 degree. This is 30 degree, and okay, so on the gravity. So to solve it, basically you have to look at, you can solve it two ways, and that's why one way I explained last week. However, I think somewhere I wrote something wrong actually. So I wrote the force term in the final equation, but force term will not be there if you assume it to be when this portion attaches this one, then this becomes a mass spring system, and from there force terms is not needed. So the solution that I posted, so you can see that today only I posted in Google Classroom. So there is another method also I gave. So you can solve using those two methods. Okay, so since details I already posted, so you can go through them. Okay, and okay, so today we want to go ahead with the chapter 5 now. Okay, so we'll go with chapter 5 questions. Okay, because I think we have a tutorial for 3 chapters left, and we have 3 weeks, and after that you have quiz, so that way it will be better. Unless you have any question in doubt, I can answer. Okay, so in the meantime, let me start with chapter 5 with, and the problem number 5.8. Okay, will be the first one. Okay, now in this chapter, there is in this problem, there are two masses, M, which is joined by to another mass And actually, those are the railway coaches, but actually finally it comes down to two masses basically, and there's a spring K here, okay? And then there is a question. The question is okay, I'm reading it. An electric train made up of two cars of some weight, each is connected by a coupling of a stiffness equal to some value. Okay, determine the natural frequency of the system. So this is asking what will be the natural frequency. Okay, so this is the system. Of course, it's a multiple degree of freedom system it is, but we have to solve it. So how to do it? First thing will be to find out the equation. How does the equation looks like? Okay, so here we can assume the displacement for first one is x2, for one this is x1, like this one, and then we have to find out the free body diagram. So let us say for number one, let's as I said earlier, you can always assume some values. Let us say we say x2 is greater than x1. If you do that, then there will be a tensile force here, right? So that means this is x2 greater than x1. It will be as if like x1 is at rest and x2 you are stretching the spring. In that case, you will get this kind of. So this is M, and you will get force backward, and force will be equal to K x2 minus x1, right? Okay, and this is at x2. Okay, and then for this one, this has M, same value, you have x1, and the force here will be the same force but opposite direction, K x2 x1. Yeah, so this is 1, this is 2, and then we can write the equation. So looking at the first one, okay, the first one, what we see M, and we have K, then x2 minus x1, and this is x1. So equation will be equal to, so we have K x2 minus x1 is equal to M x1 double dot. Yeah, so this is the first equation we get, or simply you get mx double dot plus kx1 minus kx2 is equal to 0. Now second one you have m and you have x2, and opposite direction you have force, and force is k times x2 minus x1, and hence you get minus k x2 minus x1 is equal to mx2 double dot, and hence you get equation, so here x1. Okay, yeah, so mx2 double dot plus, okay, let's write minus rather, so minus kx1 plus kx2 is equal to 0. So we got two equations. Okay, we got it. Okay, now we have two equations. Okay, so let's say let's equation number 3, equation number 4, let us say, and both of them we can write in a matrix form. Yeah, so what will be the form? So first we have M matrix, so we have M 0 0 M, and then we have x1 double dot x2 double dot not equal to, but we'll have plus and this one. So we combine this, so we have k minus k minus k k, so we get k minus k minus k k, and x1 x2 is equal to 0 0. Yeah, okay, now we have to solve it. We have to find out the natural frequency, right? Natural frequency we have to find out. So how to do? So as if you, in the lectures, you can assume the value like x1, x2 is equal to a1, a2. You can assume like this one, a1, a2, and ei omega. So spring mass system, so ei omega t. You can assume like this one. Right? Okay, and then if you put these values here, so automatically you can find out what you get. You get like this. You get m0 0 m, and then double dot. Sorry, this will be x2. So x1 double dot. So you get a1. Automatically you get, right, minus a1 omega square minus a2 omega square, right? And you get ei omega t, right? And plus you get k minus k, and you get a1, a2, and multiplied by ei omega t equal to 0, equal to 0, 0. Yeah, so here we can get rid of this, and finally, what do we get? Finally, since a1, a2, this value we will get, right? So finally, let's get rid of this one so that we just get the magnitude. And what do we get? We get finally, we get k minus k minus k, right? And then minus omega square, and then you get m0 0 m, and then you have a1 and a2 is equal to 0, 0. Okay, so this is the eigenvalue problem you get, and this we have to solve. So finally you get a k minus omega square m, then minus k minus omega square m, yeah, a1 a2 is equal to 0, 0. Yeah, you get that. So we can assume omega square equal to lambda, and simply you get k minus lambda m minus k minus k minus lambda m, a1 a2 is equal to 0. So of course I'm taking the long way to solve it, but still you can straight away you can go. Okay, so now this once you have this one, then you know that if this is true, then if unique solution exists, then determinant of that has to be 0, right? So this is basically it's not non-invertible. Basically, this cannot be inverted, and hence what we'll get? We will get determinant of that, of what? Of k minus m lambda minus k minus k minus m lambda is equal to 0, or simply k minus m lambda square minus k square equal to 0, or you get minus m lambda multiplied by 2k minus m lambda is equal to 0. Yeah? Okay, so a square minus b square equal to a plus b multiplied by a minus b. That's what I did. Okay, so this you get, and from here we get lambda equal to 0 and lambda equal to 2k over m. Yeah, lambda is nothing but omega squared. Yeah, so that it tells you is omega n, right? Omega n equal to 0. So or is that omega, right? So omega equal to 0, and this says omega equal to 2k over m. Yeah, so these are the natural frequency. Basically, these are the natural frequency. So these are the answer. Answer will be, first will be 0, and then second natural frequency will be this one. The zero natural frequency means what in this case? So we can also find out the Eigen Vector. Yeah, so these are the eigenvalues you got, and it tells you that if there are two masses or two coaches which are joined by a common spring, and then what happens is this has a natural frequency, and this natural frequency will be equal to root 2 k over m, and 1 is omega equal to 0. That really means what is the meaning of that? We can find out by eigenvectors. So how to find out eigenvectors? So here eigenvectors means eigenvectors. So remember we had a1 and a2. So we had this k minus m lambda minus k minus m lambda, and then we have a1 a2 is equal to 0 0, right? Okay, now lambda we know. So first lambda 1 is equal to 0. So put that value there. So what do we get? If lambda equal to 0, if you put, we get k minus k, and then we have a1 a2 is equal to 0 0. And what do we get from that? We get k a1 minus k a2 is equal to 0. That tells you that a1 is equal to a2 simply. Second equation also, a1 a2 equal to 0. So this tells you this only. So a1 equal to a2. So this is the answer, meaning that it tells you a1 over a2 is equal to 1. Yeah, so basically these eigenvalues, that really means both have the same displacement. So when lambda is equal to 0, a1 and a1 a2 will be equal to some value, let's say alpha and 1 1. So both are moving in the same direction at the same time. That really means that the first eigenvalue tells you that there is no frequency, means omega equal to 0. That really means it has a very high infinite time period, and both of mass are moving in the same direction. So this tells you basically that both are moving in the same direction. So they will move in the same velocity, right? So v and v, and without stretching, they can move in the same direction with the same velocity. So this is the first mode. So this is mode 1. And it's possible, right? Without stretching this spring, both mass can just slide. Yeah, so because they are free, basically one end is not fixed, so it can just roll on the rails, right? Okay, so this is the first eigenvalue is this one. Now second one also we can find out. When lambda, it says lambda is equal to 2. Second value is lambda equal to 2k over m. So you can put that. So lambda 2 is equal to. So lambda 2 equal to 2k over m. And our equation, original equation is k minus m lambda minus k minus m lambda, right? And here you have a1 a2, and here equal to 0 0. Okay, now m lambda equal to 2k. Yeah, so c lambda equal to 2k over m. So you put that value here, and we get k minus 2k minus k, and here also we get m lambda over 2k, so k minus 2k, or simply we get minus k. So minus k, right? Okay, sorry, we have to multiply by a1, a2 as well. So a1, a2. Okay, fine, and that is equal to 0, 0. Yeah. So finally, what do we get? That really means that k a1 plus k a2 equal to 0. That tells you a1 plus a2 equal to 0, or a1 equal to minus a2. Yeah, and hence a1 over a2 equal to minus 1. Right. So that means in this case a1 and a2 is given by some alpha, and then you have 1 minus 1, something like you can get. What is the meaning of that? There is a physical significance, and the physical significance in this case is like this. So you have a mass here, and there's a, so this moves this way, this moves this way, right? So this is positive direction, goes this way, this goes this way. So this one has like the mode shape, which will be like both the masses will be coming together, go away, come together, go away, you know, like this kind of motion, yeah. And the frequency is 2k omega square equal to 2k over m. So omega equal to root 2 multiplied by root k over m. Yeah. So this is the mode shape. When it goes this way, this will go this way. When it starts moving this way, it will go this way and come back. And what will be the frequency of this mode? Frequency of this mode will be omega n2 will be root 2k over m. Okay, so this is how. Okay, any question, guys? Okay, so one question we did, I solved everything, the eigenvalues and the eigenvectors. Okay, so eigenvalues tell you what is the frequency, the square of the natural frequency, and eigenvectors tells you what is the mode shape, meaning that how the masses are moving relatively to each other for that particular natural frequency. Yeah, so there are two kinds of vibration in this. Okay, now look at question 520. So okay, in 520, we have like this. So this is a center here, C, and then you have L over 4, and L over 2. Then M, K, and then JC, motor inertia about point C, which is in the middle, basically, center of mass. So ML square over 12. Okay, so this is the question. It is so here choose the coordinate x for the displacement of C and theta clockwise theta clockwise for the rotation of the uniform bar shown in figure. Determine the natural frequency and mode shapes. So finding out omega n is equal to what, and mode shapes A1, A2. So this is we have to find out. Okay, now in this, what is suggested? Is suggested that the displacement of C as the so let's say this is okay. So the displacement of C is like this. Sorry, let's beat downward. Okay, so let's say this downward is x. So coordinate x for the displacement of C. Okay, choose coordinates x for the displacement of C and theta clockwise for the rotation of the uniform bar. So let's say call it this one y, okay, and then clockwise theta. So this is equal to theta. Okay, so these are the two coordinates, displacements basically, right? Okay, now next thing will be to actually find out the equation. And how do you find out? So what we are going to do is we are going to give a displacement, right? So let's give displacement by y and displacement by theta clockwise, and then see what happens. So first of all, if this has, there will be two kinds of displacements, and one will be by x, so by y downwards. So because of that, what will happen? The displacement of this spring will be y, right? It will be y and y, both of them, right? Since you are moving this down by y, then there will be a stretch y here also and here also. Now what are you doing? Now you are going clockwise like this one. And then because of that, what will happen? So because of that, so we can do like, this is the, from here we are starting, and from there we are coming down, and the value here is y, and then after that there is a rotation about C, which is by theta. So then what happens? Right there we have gone like this. So clockwise, so it will be like this. Yeah, and so this y is because of the vertical. This one, it has 2 degrees of freedom. So this is the first degree of freedom, which is the translational motion, which is y. So which is going from here to here is y, and then you are rotating. So rotating about C. So rotating about, this is point C. Okay, and we have L/4 here. Here we have L/2. Yeah, and hence the value here. So we can write the value. Since this one is theta, so value of this one will be equal to L/4 times theta. Right? So L/4 times theta will be this value, and here it will be L/2 times theta, which will be like this one. So final, if we look at this one, the final looks like this. Final will be like this. So this is the original position, and then with both y and theta, we have values. Here this will be y minus L/4 theta, and this is here. Here it will be y plus L over 2 theta. Why? This is because distance from here to here is L over 2, distance from here to here is L over 4, because of that. Okay, so once we have that, then we can find out, basically, in that case, we can have those equation we can write, or we can have the free body diagram to begin with. Okay, so we have a free body diagram now, so we can write like this. This one, this is the original position, and then we have middle here, and then we have here, and we have here. Yeah. Okay. Now there will be a force here upward. There will be force here upward. Yeah. And those forces are, so this force will be here. It will be K, and there's a value of, let me see whether both the springs are same. Yeah, both springs are same. So we get a K times y, okay, minus L over 4 theta. By that it is stretching, and the other one will be K times y plus L over 4 theta. Why? Because theta is clockwise positive. This is what is written. And if you do that, then there will be more stretching here than here, because you have rotated this way. Okay, so these are the forces which is pulling that, right? And then you have mass here. Okay. Okay. Now the mass here has, you have the value of this is, so you put like this one, right? So from here to here you have y. Yeah, you have gone by m. So first equation number 1 will be, you see what is the forces, and the forces are summation of all the forces in y direction will be 0, and hence you get minus K y minus L over 4 theta minus K y plus L over 4 theta, sorry, L over 2 theta, this L over 2 theta. Okay. So L over 2 theta is equal to my double dot, right? Okay, as usual, how you write, we wrote like this one. So this equation is nothing but my double dot, right? Then plus 2ky, right? 2ky, and then you have plus k L over 2. So this one negative sign here, so it becomes positive here. So k L over 2, and here this will negative plus positive, and then it comes here to negative. So k L over 4. So but negative, right? So minus k L over 4, then theta, yeah, is equal to 0. So you get one equation. Now second one will be a summation of moments about C is equal to not 0. Okay guys, here this is not 0 but my double dot. Yeah, so like, so it is not a static problem, so hence we will have my double dot, and here this will be summation of all the force moments about point C. Yeah. Okay, so has to be equal to JC. So we have JC given, okay, JC, and then theta double dot. Yeah. So in rotational system, we have this equation, right? Okay. Now next is we have to write the equation, and we have assumed that the clockwise will be positive, and hence accordingly we have to look at it. So what do we see? We see there is a moment created because of clockwise moment will be created by this one, and anti-clockwise by this one. So this will be minus. So our equation will be k times y minus L over 4 theta multiplied by L over 4. So from here to here is L over 4. Yeah, so this is the lever we are applying, then minus, and then we have k y plus L over 2 theta multiplied by L over 2. So this is L over 2 from here to here, but since this anti-clockwise, so we are writing minus. Yeah, and that is equal to JC theta double dot. So this is second equation, and our equation we can write in final form. So second equation will write JC theta double dot. Okay, and then we can write. So here if you look at this is ky, and this is minus ky, so they cancel out automatically. And then what we have is we can have kl over 2 theta, and here this is a minus, so kl over 2 theta and kl over 4 theta both has minus only. So here minus becomes plus, this minus becomes plus. So finally what we get is plus kl over 2. Okay, so this is k l over 2 l over 2. So k l square over 4 theta, k l square over 4 theta, and plus, and from here we'll get k l square by 16, and this minus so becomes plus. So becomes k l square by 16 theta is equal to 0. Yeah. So this is what we get. And okay, just a minute. Okay, I think I made a mistake. Okay, why I made a mistake? Because here this y is multiplied by L over 4. This y is multiplied by L over 2. So it will not cancel out. Okay, so we have to write a net. So what it will be? So this is k minus k L over 2. This becomes minus becomes plus. So we can write here. So let's not write this one yet. So plus k L over 2, okay, times y, k L y over 2. So this is k L y over 2. This becomes k L y over 4, and this will be minus because this is a plus. Okay, so this so minus k L over 4 y is equal to 0. Okay, so we can write final form will be JC theta double dot. Then let's write y terms becomes KL over 4 y, and then becomes plus, and this one 4 here 16, 5 over 16. So 5 over 16 KL square theta is equal to 0. Okay, so this one is equation number 1, and this is equation number 2. Now we have to arrange them together. And what will be the equation? So look at that, both of them. So we can write like this. So we have first is m, right? So we write here m, m0 0 JC, right? Okay, and then equation will be here y double dot and then theta double dot plus, now we have to write the k term. So okay, go back, and here we have, okay, so we are going to write y and then theta. So y multiplied by 2k, and here this multiplies with theta multiplies by kl over 4. So total will be kl over 4. 2k kl over 4. Okay, so 2k kl over 4. Okay, done. Now the second equation, so let's write like this one, and here we will have y and theta is equal to 0, 0. This is the equation. Okay, now we have this one from the first equation. We get this multiply this multiplied by this equal to this multiplied by this equal to 0. So first equation complete. Second, we have to write this one. And how do we do? So second equation is JC theta double dot. Then we have KL over 4 y. So that means we have KL over 4 here, and then we have 5 over 6 KL square. So 5 KL square over 16. Okay, so 5 KL square over 16. Okay, theta. So this is the final equation we get. This is the final equation we get, and next is finding out what is the natural frequency. So once you get that, natural frequency will be just we in order to find out the natural frequency, what do we get? We do like this: k minus lambda m, and determinant will be equal to 0, right? For the reason that I explained in the previous example when I was solving, and that really means this: we have a k. This is a k matrix, right? This is the k matrix. This is the k matrix. This is the m matrix. So 2k minus m lambda. 2k minus m lambda. So we get 2k minus m lambda, and then we have kl over 4. So kl over 4. Here also kl over 4. Okay, and then here you have JC here. So we get this minus lambda JC. So 5 KL square by 16. 5 KL square over 16 minus JC lambda. Sorry, determinant equal to 0. Remember that we also have a JC given, right? So JC is ml square over 12. It is given in the example, in the question. So JC equal to ml square over 12. Yeah, this is given. Okay. So that means we can put this value here also, basically. Yeah. So and we can solve this way. So anyways, so we have this equation from, we can find out the lambda. Yeah. So finally our equation becomes 2k minus m lambda multiplied by 5 KL square over 16 minus JC lambda. Yeah, and then minus k square L square over 16 is equal to 0. And you can find out lambda here. Lambda will gives you the natural frequency. Lambda equal to omega n square. Yeah. Okay, so we can do that. So we put JC equal to ml square. Let us see what happens. So 2k. So 2k minus m lambda, then J equal to m L square over 12. So, so L square over 12. Okay, let's put it right there. So KL square by 16, 5 KL square over 16 minus 1 over 12 ml square, that is JC multiplied by lambda minus K square L square divided by 16, K square L square divided by 16 equal to 0, or so we have L square which is in common. So if you see L square which is in common, so we can get rid of that. Okay, so finally we get 2k minus m lambda. Then we have 5k over 16 minus m lambda over 12 minus k square over 16 equal to 0. Yeah, and rest we can solve. Okay, so we can, and so on. I will just write because of the time we don't have. So expand, solve this equation and find lambda. Okay, lambda equal to find lambda, and omega n will be equal to root lambda. There will be two values, right? So you get this is quadratic equation, so you get two lambdas, and those will be the natural frequency that we have to find out. So once you find out the natural frequency, you can find out the eigenvalues, and for that what do you have to do? You have to do like k minus lambda m. So you put a value of this is a k matrix, this is lambda, actual lambda you can put it here, then m, and then you have a1 and a2 will is equal to 0, and then you have to solve for a1 and a2 This will be give you the eigenvectors. This is the eigenvector. So eigenvectors are the mode shapes basically, right? Mode shapes. The way we solved for the previous problem, same way we have to do. So any question, guys? Anything? Any questions? So this was chapter 5. Okay. So the multi-degree of freedom system. And tomorrow you have a quiz starting 4 o'clock from 4 to 5. And it will be on Moodle as announced, and it will have similar questions that you got for the homework, you know. So means, but you will have 25 questions to be solved in 60 minutes. Okay. Any confusion? Anything you want to ask? Okay, so rest of the tutorial problem you can solve the similar way. Okay, and please solve the tutorial problem. They are very important, you know. So unless you know the fundamentals, it will be difficult to solve your quiz problems or mid-sem exam or the end-sem exam. So very important that you understand it. Just by applying formula, it will not help. Okay, so understanding is important. Okay, guys, that is all. If you don't have any question, okay. All the best for your quiz tomorrow.